Welcome to the DIY Honda Garage channel. The DTC code P2183 indicates a potential issue with the Engine Coolant Temperature ECT Sensor 2. This sensor measures the temperature of the coolant and is critical for the vehicle's Powertrain Control Module PCM to optimize engine performance and efficiency. The ECT Sensor 2 is typically located near the engine block or cylinder head, facilitating direct contact with the engine's coolant. When this code triggers, it suggests that the signal from the ECT Sensor 2 is outside the expected range, which could lead to improper engine tuning, increased emissions, or overheating. This problem may be caused by sensor malfunction, wiring issues, or connection faults. Addressing DTC P2183 promptly is crucial to ensure reliable vehicle performance and prevent potential engine damage. DTC P2183 specifically concerns ECT Sensor 2, which is essential for measuring the coolant temperature in the engine system. This temperature data helps the PCM make adjustments to fuel injection and ignition timing, ensuring optimal engine performance. The ECT Sensor 2 is generally located close to the engine block, allowing it to accurately gauge the coolant as it circulates through the engine. When the ECT Sensor 2 reports a reading that doesn't match its expected range or performance criteria, it can trigger a performance problem DTC, implying that either the sensor itself is defective or there are issues with its associated wiring or connectors. Identifying this problem early is vital for the health of the vehicle's engine system, as it directly impacts engine management strategies. Several possible causes can lead to the triggering of DTC P2183. First, poor connections or loose terminals can disrupt the signal sent from ECT Sensor 2 to the PCM, resulting in inaccurate readings. This can happen due to corrosion, dirt, or physical damage. Second, the ECT sensor itself may simply have failed, leading to a complete lack of signal or a signal that falls outside the expected range. Lastly, wiring issues can arise from frayed, broken, or shorted wires, which can interfere with the proper functioning of the ECT sensor and should be thoroughly investigated. Each of these aspects needs to be carefully checked and resolved to ensure proper engine coolant temperature monitoring. With DTC P2183, several symptoms may become apparent during vehicle operation. The most notable symptom is the potential for engine performance issues such as rough idling, stalling, or decreased acceleration, which result from improper fuel management by the PCM. Additionally, increased emissions could occur as the engine fails to burn fuel efficiently, leading to possible failures during emissions testing. Lastly, if ECT Sensor 2 malfunctions significantly, the engine may overheat due to incorrect temperature readings, preventing the cooling system from engaging as needed. Being aware of these symptoms can help a vehicle owner identify potential issues early and take appropriate action before more significant damage occurs. The first step in troubleshooting DTC P2183 involves conducting a visual check of the connectors and electrical terminals associated with ECT Sensor 1 and ECT Sensor 2. This step is crucial because poor connections can lead to intermittent or faulty signals being sent to the PCM. Inspect the terminals for any signs of corrosion, dirt, or physical damage, and ensure that they are securely connected. If any loose or damaged connections are identified, they should be repaired before moving on to the next step. Should the connections appear to be in good condition, you can proceed with further diagnostics to isolate whether the issue lies within the sensors or other components. In the second step, you need to turn the vehicle to the on mode without starting the engine. This allows the Honda Diagnostic System, HDS, to read any stored diagnostic trouble codes, DTCs, including both pending and confirmed DTCs. It is important to check if DTC P011A is also present simultaneously with DTC P2183. If both codes are indicated, this suggests that both ECT sensors are potentially malfunctioning, and you should proceed to a more in-depth troubleshooting process outlined in Step 5. If only DTC P2183 is present, you can move on to checking the performance of ECT Sensor 2 as suggested in the next step. In the third troubleshooting step, you'll need to start the engine and allow it to idle for at least 10 minutes. This prolonged idling is essential to stabilize the engine temperature, allowing the ECT Sensor 2 to provide accurate data. During this time, utilize the HDS to read the parameter values associated with ECT Sensor 2. You will specifically check if the current conditions reflect a temperature reading below 120 degrees Fahrenheit or 49 degrees Celsius. If the ECT Sensor 2 value matches this threshold, it indicates a potential issue with the sensor itself, leading to a recommendation for replacement. However, if the readings are out of range, you will want to proceed with verification to confirm whether the sensor's failure is genuine. Step 4 requires you to turn off the vehicle completely. Then allow the ECT Sensor 2 to cool down to the ambient temperature. Ambient temperature refers to the temperature of the surrounding air and should be noted for reference. Once the sensor has cooled, you'll turn the vehicle back to the on mode to check the data from ECT Sensor 2 once again using the HDS. The critical check here is to see if ECT Sensor 2's reported value varies by 5.4 degrees Fahrenheit, 3 degrees Celsius, or more from the ambient temperature. A significant difference indicates a failure in the sensor, and it would be necessary to replace the ECT Sensor 2. If no significant difference is noted, further investigation into connection issues at ECT Sensor 1, ECT Sensor 2, or the Powertrain Control Module (PCM) is warranted. The fifth troubleshooting step involves checking the performance of ECT Sensor 1 in the same manner as ECT Sensor 2. Start the engine and let it idle for 10 minutes to ensure that you get a correct reading. Once the engine is warmed up, utilize the HDS to evaluate the parameters associated with ECT Sensor 1. The same threshold condition of being below 120 degrees Fahrenheit, 49 Celsius, applies here as well. If the current conditions indicate that ECT Sensor 1's reading is below the threshold, you should replace ECT Sensor 1. Conversely, if it's operating within the expected parameters, this suggests that ECT Sensor 1 is functioning correctly, and you should proceed to assess ECT Sensor 2 again in the next step. Step 6 involves repeating the performance check for ECT Sensor 2, similar to how you assess ECT Sensor 1. Again, allow the engine to idle for a full 10 minutes to stabilize the engine and coolant temperatures, ensuring an accurate reading. During this step, monitor the ECT Sensor 2 parameters using the HDS, focusing on whether it complies with the threshold of being below 120 degrees Fahrenheit or 49 degrees Celsius. If ECT Sensor 2 is not within this threshold, it indicates that the sensor is faulty and should be replaced. Otherwise, if the conditions match, you will proceed to the final step of verifying if there are other underlying issues, particularly focusing on wooden connections and other components in the circuit system. In the final troubleshooting step, you'll begin by turning the vehicle to the off mode and allowing both ECT sensors to cool down to the ambient temperature. After noting the ambient temperature, switch the vehicle back to the on mode and utilize the HDS to check the values of both ECT Sensor 1 and ECT Sensor 2. It's essential to compare these sensor readings individually against the ambient temperature, and if either sensor reports a value differing by more than 5.4 degrees Fahrenheit, 3 degrees Celsius, it indicates a malfunction, necessitating a replacement of that specific sensor. In the absence of such differences, an intermittent failure may exist, and you should check the connections or terminals related to ECT Sensor 1, ECT Sensor 2, and the PCM. If any freeze data or onboard snapshot has been recorded, you might also attempt to replicate the observed failure to narrow down the investigation further. In the final repair verification phase, it's important to ensure that all connections and terminals have been thoroughly checked and repaired if necessary. After replacing any faulty sensors, you will want to confirm that the new sensors are functioning as expected. Utilize the HDS to recheck for any DTCs following the repairs. Ensure that the ECT values observed are stable and do not indicate out-of-range conditions. If the readings are consistent and within normal limits, the repair can be deemed successful. This step solidifies the integrity of the repair work and ensures that the vehicle is operating optimally moving forward. To prevent future occurrences of DTC P2183, it is essential to incorporate preventive maintenance measures focused on the ECT sensors and their associated connections. Regularly checking the condition of ECT sensors can help detect any issues before they trigger a DTC, providing early warning of potential failures. Additionally, conducting periodic inspections of all electrical connections related to the ECT sensors ensures that any corrosion, wear, or loose terminals are addressed in a timely fashion. Keeping the vehicle's cooling system clean and exchanging coolant at manufacturer-recommended intervals will also help maintain optimal sensor performance. By proactively maintaining the ECT system, vehicle owners can avoid costly repairs and ensure smoother engine operations. In conclusion, understanding DTC P2183 allows Honda HR-V owners and technicians to address engine temperature issues effectively. This diagnostic trouble code signifies that ECT Sensor 2 is presenting range or performance problems, which can result in engine inefficiencies if left unattended. By following the systematic troubleshooting steps, from examining sensor connections to replacing faulty components, owners can maintain optimal vehicle operation. Utilizing preventive maintenance and being observant of symptoms can minimize the occurrence of these types of issues. Ultimately, early detection, prompt repair, and regular vehicle diagnostics will ensure a reliable and efficient driving experience. Please like and subscribe to the channel. See you next time.